So the next speakers that are going to do it a little bit differently. It's going to be a bit more of a group session. So I'd like to welcome Emma McCrabb and Elise Bowen. So both Emma and Elise have been involved in sheep genetics. So Emma as an employee of MLA and as Elise as a service provider to the sheep genetics team. So today they're going to talk a little bit about controlling inbreeding. So we make selection decisions, we make genetic progress, and sometimes we have to be aware that when we pick animals, they're related. So of course we can have things that are detrimental to breeding programs, and we have to manage those as well. And so they're going to give us some information and a rundown about how some of those tools can be utilised.
Thank you, Sam. So today, Elise and I were going to tag team it a bit. So I'll start off by going through the principles that sit behind the way that we talk about genetic gain and relationships, go through a bit of a crash course in those principles, and then I'll hand over to Elise, who'll actually go through sort of the more fun stuff, the nitty-gritty of how to actually approach managing this, particularly with your clients. So any breeding program is a balancing act. This one here is a bit of a sheep focus, but we know across beef and sheep we're trying to balance the use of breeding values with making sure those animals stack up visually and structurally. Particularly merino operations, we're trying to balance often competing products, as JB was just showing us, between wool and meat. And we're also trying to balance the amount of genetic gain we're making, but also the relationships between those animals. And we have a tool that's available to both beef and sheep in this space that helps improve the efficiency in the way that breeders can do that, and that is Matesel. I know a few of you in the room will be aware of Matesel. We've got a few users, so I'm just going to quickly go through what Matesel is as a program before we actually start to apply it to some real animals. So Matesel was developed by a fellow called Brian Kinghorn. He's based up in Armidale at UNE. And it's a program that makes selection and mating recommendations for a really wide range of activities. So it's not just applied to sheep and beef. The same principles are applied across the prawn industry, tree industry, so all different types of breeding programs that are out there. Key focus of Matesel is that it wants to balance the genetic gain you're making with the genetic diversity or the relationships between those animals. So it actually focuses on the next generation or the progeny that are produced rather than the parents that are being selected. And it does that by defining relationships in two ways. The first is the one that we've all heard of, which is inbreeding, which is where we're mating related individuals, and we're generally doing it for a reason. We want to mate the best animals with the best animals, so we end up with good genes on both sides of that pedigree. However, we know there are risks associated with inbreeding. We run the risk of depressing certain traits like fertility when we get to a certain inbreeding threshold, and we also run the risk of recessive genes coming together. Matesel also defines relationships through a term called co-ancestry. So on paper, that is the measure of common ancestry between animals. But if we actually apply it to an example, what I've got here is I've got a scenario of high co-ancestry. So in this case here, we've got 100 ewes, and what we've done is we've mated all 100 ewes to the one sire. What that means is the next generation are all half siblings. So we've really limited our options in terms of genetic variation for the next generation and what we do in terms of joining selections over the next few years. If you compare it to a scenario of low co-ancestry, I've got those same 100 ewes, but this time I join them to 5 genetically different rams. This time I've got much more genetic variation and diversity, so I've got plenty of options in terms of where to go with my next round of joining decisions. So there's two ways that we tend to see Matesel being used. The first is in allocation, so where you come to Matesel, you've got your list of rams and you've got your list of ewes and you just want it to allocate rams to ewes. But as the name implies, we actually see a lot of power if you use Matesel in selection decisions. So where you give Matesel an excess of rams and an excess of ewes and actually allow it to pick the best options and allocate them accordingly. So having a bit of a deep dive into, I know I've talked a lot about sheep here. The Matesel program works the same in beef. So wherever I say rams, you can also say bulls. But the sheep genetics Matesel system is using the same technology that beef do. We just have a slightly different interface, so the part that the breeder is interacting with. So all a breeder needs to do when they're using Matesel is supply the sheep genetics ID of that animal, and we will pull on the depth of pedigree on that animal, as well as all of its breeding values. It also means you can do a bit of online shopping with outside sires before you've joined them. So you can chuck a couple of outside sires that you might be looking at purchasing semen for, and actually see what Matesel would do with those sires in that next joining. So we have over 200 users of Matesel through our sheep genetics portal. So most of those are breeders, and we also have 75 service providers like Elise who are running Matesel runs on behalf of breeders as a service. So we're running really regular trainings. This is the crash course in how Matesel works, but we do have a fairly intensive training to make sure that you understand how the program works, given there's a fair bit of power there in using Matesel. And then we also run refreshers. We know with things like this, often we're only opening it once a year at joining. So we run refreshers pretty regularly to make sure you're aware of the power of the program. Two cool things I'm just going to pull out of when we are lining up to do a Matesel run that I see practically as really important. The first is you can include strategic information in Matesel. So information on your breeding objective, as we've talked about so much up to this point, and an index that best aligns with what you're trying to do on farm. You can also add in traits. So similar, I've got a breech wrinkle example here which builds on what JB was talking about, but we can actually say, okay, I want to use this index, but I understand breech wrinkle's not in that index, so I'm going to put additional emphasis on that trait. You can also include information on practical decisions. So, for example, if you've got a certain number of doses of semen that you really want to use up this year, you can actually tell Matesel to allocate that sire a certain number of times because you just want that semen out of the tank. I'm going to breeze over this concept. Anyone who does want to use Matesel in the future, come and have a chat to me about it, but just given time constraints. The first output that we get out of a Matesel run is a frontier. So what this blue curved line is doing is it's describing the potential that's out there based on the rams and ewes that you've supplied to Matesel. So along the bottom, we've got our measure of co-ancestry. So further to the left means that the next generation are less related to each other. And we've got genetic gain on the vertical axis. So again, the higher up that vertical axis means you've got a higher index in this case. So what this frontier does, and we're not going to focus too much on it today, but it just describes what potential is out there. So based on those rams and ewes, what is the maximum that you could achieve with these animals? And I mentioned that you can also include traits. What we then can look at, so from the output of a Matesel, you supply your ram lists and your ewe lists. The outcome is you get a list of rams mated to ewes, but you also get mid-parent breeding values from that. So what we can actually do is we can predict how the next generation are going to perform before we've even joined the rams to the ewes. And so that way we can actually have a look. So in this example here, we've got birth weight, and it shows you the distribution in the progeny for birth weight. However, we might have a breeder who he has a really strict attitude on birth weight. He doesn't want anything over 0.4. So what we would then do is go back and reassess our Matesel run and say, okay, I'm going to put a hard threshold on 0.4 and see if Matesel can abide by that rule. I'm going to hand over now to Elise, who's going to go through the actual mechanics of Matesel.
Thanks very much, Emma. So I'm going to run through a case study which is loosely based around a real life scenario, but I've simplified it a little bit for the purpose of not overwhelming you with too many different options. But here's sort of the bones of the case study. So I've selected to do a natural mating program, and the reason why is because a large focus of this talk was around managing inbreeding, and usually when you're doing a Matesel for an AI program, you're bringing in external sires, so inbreeding isn't usually such of an issue. However, in this scenario, the AI ewes have already been taken out of that pool of ewes, so we're left with a balance of ewes that are going to be joined to rams that have been bred in the stud, so they will be more closely related to the ewes. A few traits that I've picked out that we want to place emphasis on are early growth, so weaning weight, whilst managing birth weight, so making sure it's not too high is what I mean there, and maintaining eye muscle depth. And the target index I've chosen for this example is the maternal carcass production plus index. Given relatedness to the stud ewes, I've opted to try and maintain individual progeny inbreeding below 12%. The exact threshold that each breeder has in their breeding objective for inbreeding is quite a personal thing. So some people have much stricter threshold and others a bit more flexible. As I mentioned, co-ancestry is less important in this example because the AI progeny will be coming in to be the future sire team. So we're not too worried about if this cohort of lambs from this joining program have a little bit higher co-ancestry. So this is my suggested approach and the way I approach most of my Matesel runs, and I'd sort of suggest that you follow something similar. I usually start with a base run where I don't put any trait restrictions in, because as soon as you put in restrictions on traits or restrictions on sire usage or restrictions on inbreeding, you'll see the bounds of what's possible. You just can't reach the bounds of what's possible in that frontier graph, and I will bring up a frontier graph shortly to show you what I mean. But if you really leave all the options on the table, you can see what's possible, and then you can start to refine some of your targets and put in some parameters, and then you can see what effect that has on reducing, I suppose, your ability to capture that genetic gain. So I usually add in some target traits, but I turn them off. So they're there and I can see what the movement is in those traits, but they're not influencing the run at all. This allows you to then check the co-ancestry and the progeny inbreeding levels and see if they need to be tweaked at all, and I will tweak them in my example. And then finally turn on those target traits if required, and the if required thing's important because it might not be required when you look at the output from the run. And if you do need to rerun, you can do that with some of the traits turned on to just refine the distribution of ASBVS. So I'll run through these 4 steps quite quickly. So one of the setup screens when you're starting a run is to input the candidates for the dams and the sires. So this is just the screen where I'm inputting the individual sires, and I'm setting some realistic usage parameters. So if I want, in this example, to use a ram in a allocate a paddock to a ram, I'm saying he needs to be used at least 30 times. To have less than 30 ewes in a mob is not going to be feasible. There's 350 ewes in this group, so I don't have that many paddocks that I can put less than 30 ewes. And at the same time, I'm considering maximum usage, and I've put 60 here in this example, and some people do change it compared, if it's a ram lamb versus a mature ram, or if it's a ram that, has really highly accurate ASBVs and I'm happy to use him more times, but I might have a young ram with not so much accuracy and I don't want to overuse him because that's increasing my risk. So I've just set blanket minimum 30, maximum 60. None of them are must-use sires. You can choose to use them or not, but you can make them an absolutely must-use sire if you want to. The first piece of output I get from this base run is the frontier, as Emma's already shown you a frontier. So it's got the bounds of what's possible in terms of index gain and also that range in co-ancestry. So the green line is the strategy that I've chosen, which is essentially to put most of the weighting on index gain, and where it hits that frontier at the top is the result. And I can see, because I've put in a few small constraints around the inbreeding and the sire usage, my end result, or that little yellow dot, has hit the frontier, not quite at the point of the green line, because I've put in some small parameters there. And some of the other output will show me, I suppose, some of the key things that I'm looking at. Firstly, it shows the number of female candidates, so I can just check, yes, it is selecting to join all those ewes. So in this case, I'm not using Matesel to select which female candidates to use. I'm asking it to join them all. You do have the option, if maybe I only wanted to join 250 ewes, that it would actually choose which of the 250 ewes to use. In this case, I've used them all, but you can see with the male candidates I've put in 14 and it's only chosen to use 7. On the right hand side we've also got the value for co-ancestry there, which is 5.8%. We've got some average indexes of the progeny on the left-hand side and the lowest selected index of the males and females. The value that I'm really taking out of this slide though is that proportion of matings that are over my inbreeding threshold. So where I've got the red arrow there, I've set the inbreeding threshold at 12% and put a weighting on there to try and discourage the program slightly from doing that, and I can see that I've got 6.3% of the matings are over that threshold. So that's something that we can dive a little bit into and have a look where they're occurring. So the Matesel output Excel file is huge, and it lists pretty much every trait and index that's available. So I like to open it up and just really delete all the columns that I'm not interested in, try and strip it back to some of the key traits in my objective just to simplify it. And then you can see the allocations are there. So the first column is the ram that's been chosen, the second column is the ewe that it's been joined with, and then we've got all the mid-parent breeding values of the progeny resulting from those joinings. And I've just sorted, there's 350 joinings in this file, and I've just sorted by that inbreeding column and highlighted in yellow the ones that are over my threshold just for the purpose of this exercise. And we can see that there's one quite highly inbred mating at the top there, 26%. When I looked into the pedigree of this theoretical progeny, it was joining a ewe to her father. So if you join a ewe to her father, you get around that 26% inbreeding value. The others below there are varying degrees of relatedness. So we would quite commonly see half siblings being joined with each other to get that sort of higher, 18% type value. So whether or not this is an issue, depends on the individual breeder and what their thresholds are like, but it's certainly something you can have a little bit of a play around with. And I've just, on the right-hand side there, put up the sire allocation table. So you can see the full list of the 14 sires that were put in, and the 7 that have been chosen and how many times they've been chosen to be used. So as we start to manipulate the run, we can see how the sire allocation changes. So there was 6.3% of matings above my threshold. If this is of concern, we've got 2 pretty clear options. One is that we can actually put a stronger weighting on that inbreeding threshold and tell Matesel this is quite a bit more important to me, so please, have a bit of a think about that next time and hopefully bring that value down. We can also consider bringing some alternative sires who might be less related to the ewes and could be good options to substitute in. So I'll just do those 2 options and have a look what happens. So this is one of the setup screens in the Matesel run where you can alter the emphasis that you're putting or pressure on the inbreeding threshold. So that one right at the bottom there, the base runner had a -1 weighting on inbreeding, and now I've increased that to -10. We'll see if it does anything. So straight back into the same screen with the output, and what's actually happened is there's been no change to the sire usage or the number of matings over that threshold. So all the rams have been used exactly the same number of times. And I suppose the reason I can explain why does this happen is because those sires would be very high indexing sires. So the program in its strategy is actually saying, look, I'm happy to have some higher inbreeding matings there, because in the pursuit of genetic gain, which I'm measuring by index, that's the balance that we're sort of playing with. So you could then, increase the weighting again and see what happens, but I tended to jump to option 2 and just see what happens by adding in additional sires. Then we can weigh up those options before going further. So I've added in 4 additional sires, which should be a little bit less related to the ewes, and rerun, and we can see what happens there. So there is a slight improvement with the range of values of co-ancestry. I think the first run went up to about 6.5% for co-ancestry, and this one's down to about 5.5%. So already I'm sort of expecting there to be less relatedness in the overall population. but what about, I suppose, that inbreeding? And there is a slight reduction, not a huge reduction, from 6.3 to 5.1% of matings. And again, for most people, this might not be an issue at all, but for some it will. So we can see that those 4 new sires we've added in yellow, one of them has been used, and we've fully substituted out one of the other sires that was used previously. One of the important things to consider with Matesel is it works on balancing co-ancestry with genetic gain, and they measure genetic gain with an index. And for most people, we need a balanced approach where we're actually looking at key traits in our objectives. So before I go too much further into tightening up my run with inbreeding, I actually want to just check that the traits are sitting where I want them to be. So I can grab that output from Matesel and have a look at the range in progeny ASBVS across those key traits. And in particular, I want to focus on birth weight, weaning weight, and eye muscle depth were the 3 identified at the beginning as being of the most importance. And I can have a look for birth weight, for example. The maximum birth weight in the matings goes up to 0.8, which is far too high for this producer. So we want to set a target to have the matings below 0.6. Weaning weight, which is obviously antagonistic to birth weight, so this will be a challenge to see how it goes, but weaning weight, we actually want to bring up that minimum weaning weight, which is currently 6.3. We want to try and bring those up, if possible, to above 7.5. And eye muscle is sitting in a pretty good range, but why not try and bring up the minimum eye muscle at the same time? So we can plug those trait parameters into our Matesel run, basically turn those traits on and choose, do we want to increase them, decrease, or set sort of a maximum minimum boundary. So in these cases, I've set minimum boundaries for weaning weight on eye muscle and a maximum boundary for birth weight. And then rerun, and you can see what happens. And the first thing I noticed in the output that happened that really surprised me was that the proportion of matings over that inbreeding threshold dropped quite significantly. And the reason why is because one of the higher indexing sires was resulting in quite a few of those higher inbreeding matings, and he drops out because he was a really high birth weight. He had great growth, but he had a really high birth weight. So he's suddenly not desired by Matesel anymore, and that has corrected a few of our inbreeding issues. So that ram at the bottom of the sire list on the right-hand side who's dropped out. So that was a very favourable outcome. We've tweaked our traits a little bit, but we've also helped to address some of the inbreeding issues. So just to have a look at what's happened with the traits. So this is now the, I suppose I compare between the first run and the second run with when I turn those traits on, how many matings did I have outside of those parameters or those targets? So once I've turned birth weight on, I've actually got all my birth weights below that threshold now, which is really fantastic. But the sort of trade-off or flip that happens with weaning weight is we have had a little bit of a favourable response, but because those traits are quite antagonistic, there's always a trade-off. So Matesel's done a great job on birth weight. Maybe I could have a little bit of a play around with weaning weight to try and further reduce the number of matings that are outside my parameters. Eye muscle has similarly made a modest improvement. So really you play around with this as long as you want and do lots of reruns to try and really tweak it. Just tried to keep it quite brief, but that's the sort of overview of the process that I would go through. And a few key messages at the end. So Matesel obviously helps to balance genetic gain and diversity, making sure that we have future options for joining those progeny that are resulting from the program. It's important to set a clear breeding objective, so choose the target index or the most appropriate target index that aligns with your breeding objectives, because Matesel does use that as the primary measure of genetic gain. But do multiple runs to find the right outcome for you and play around with sire allocation and also with traits. Okay, thank you.